Welcome to Tetryonics. In this lecture, we'll be covering the quantum geometry of photons and electromagnetic waves, or light. This lecture forms part of the ebook series, particularly ebook 2, Quantum Electrodynamics, and it's available on Google Plus or on YouTube. Heat in all its forms is created through the presence of equilateral mass-energy geometries within any region of space. As increasing numbers of equilateral energy quanta come together to form square energy levels, we have various forms of mass energies being created. They range from heat itself, or blackbody radiation of particles, through to the combustion process of chemical elements, as in fire, and increase up into gamma rays and other forms of EM waves or light. In all the cases, the energy itself is in the form of equilateral geometries. As illustrated on this page, Tetryonics represents the two forms that exist of these equilateral geometries, namely positive and negative charges. In fact, these two forms are opposite sides of the same quantum coin. And as discussed in previous lectures, the equilateral geometry is a measure of angular momentum, or quantized angular momentum, and the energy content is a form of mass. So in fact, what we have here with equilateral energy geometries when measured per unit of time is in fact mass quantized angular momentum, or mass alpha as it's termed in Tetryonics. This has been expressed formally in historically within physics and quantum mechanics, electrodynamics, as Planck's constant. In fact, it was Planck's discovery of this constant that led to the development of quantum mechanics itself, and further later on with Einstein, as he strove to understand the photoelectric effect within elements. Tetryonics brings geometry to the mathematics of QED, QM, and through the geometry we can show the various mathematical relationships of wave functions, photons, electromagnetic waves, etc. Obviously, with the geometry, we can now draw visual aids to understanding the mathematics, and in fact many of the erroneous assumptions that have developed from the mathematics are now clarified using the equilateral geometry of Tetryonics. As you can see here, the equilateral triangles of energy have a faint superpositioned rotational vector in the illustration. In the case of positive charges, they rotate clockwise, and in the case of negative charges, they rotate anti-clockwise. Rotation of the particle, or the energy quanta, does not affect this rotational vector, and the rotational vector itself is purely an aid to understanding the electromagnetic properties, or the permittivity and permeability of EM fields of energy. It's not necessarily there, and in fact it's a visual aid, as I mentioned. The reality is the energy in both the magnetic and electric forms is an equilateral geometry. As we touched on in the previous lecture, the E-field permittivity is a diamond-shaped field, whereas the magnetic permeability is comprised of a dipolar field of a north and south pole, and each pole is a single equilateral geometry. The two distinct geometries gives rise to different properties. For example, in the electric force, it will diminish following the inverse square law, whereas magnetic dipoles diminish following the inverse cube law. Again, we can draw these in a number of different ways as illustrated on this page for various systems or various things that we want to model. Of note is the fact that one Planck quanta, or Planck nu, as indicated here in orange on the left hand corner of equilateral triangles, indicates odd numbered bosons. When Planck developed his formulation for energy, he expressed it as E equals n Planck nu. Tetryonics redefines these definitions in accordance with the square energy fields. Scalar energy, or total scalar energy, is a square number, whereas the bosons that make up these square numbers, or the quantum levels, are all odd-numbered geometries. So Tetryonics lists Planck nu as being an odd number of quanta, i.e. a quantum level or a boson of charged energy. And in the case of scalar energies, you'll see it listed throughout Tetryonics as Planck nu squared. Obviously on this page here we have in the right hand corner of the equilateral triangles a half F, a common misconception that arose from the poor understanding of the geometry of physics and the application of mathematics to the field of quantum mechanics, is where Planck's h nu is equated directly to Einstein's hf for the energy of photons. Planck was measuring the boson energies and the changes of the energy levels within the blackbody radiations. Einstein was measuring the release and the specific frequencies of light emitted through or energy through the photoelectric effect. Planck nu does not equal Planck F. Quanta does not equal frequency, is another way of expressing this. It takes two Planck quanta, i.e. a positive and a negative charged quanta, to make a single photon, or a frequency of light. You'll see noted throughout Tetryonics that this equates, using mathematics to say Planck's h nu equals hf is equivalent to saying 1 equals 2, or 2 equals 1 in the case of quanta equals frequency. By correcting for this anomaly, we see that the equilateral geometries, even though they are square energies, in the case of a single quanta of mass energy, h nu, 1 quanta, we would in fact have a half frequency. And in fact, when you go looking for mathematical definitions of 0 point energy and 0 point fields, you'll find in fact that they are specified as being E equals a half hf. So Tetryonics shows that the Planck's constant, or a single quanta of energy, a charged quanta because it is an odd number, it is 1, a single quanta of energy has an electromagnetic field comprised of an E field and a magnetic dipole. There are no monopoles, and it is in fact 1/2 of the pairing that creates a photon. So the 0 point mass energy is in fact the 0 point field. As we've discussed in previous lectures, Tetryonics has a unified field equation for energy for all of mass, all the charged geometries of mass, energy, and matter. In this case, the energy component of the unified field is expressed as mass alpha nu squared. This can also be read as Planck's constant nu squared, or again in the classical formulation of mass velocity squared. They are the same relationships as indicated here on the left-hand drawing of equilateral mass energy. It's an equilateral geometry. It's made up of h nu quantum levels, and these quantum levels combine sequentially to form square energy levels. And again, as we've discussed in previous lectures, these square energy momenta within the equilateral geometry create a linear momentum as a result of summing up all their individual energy momenta, which of course will create or is proportional to a velocity, or the square root of the squared quanta number. In this picture on the left hand side we have a large E for the energy field, and obviously the colorings indicating the electric permittivity and the magnetic permeability of the field itself. As we have a unit measurement of time of c squared, indicated as the radial circumference around the circle, circumscribed, we also have a measurement of mass. Energy per c squared, or per unit of time, is a form of mass. So in this example here we have a scalar geometry of electromagnetic mass energy. And again, in the unified field equation, to convert this energy equation into mass, we simply add on the electromagnetic field, which has a value of 1 over c squared. So we have energy in this case, where we measure the electromagnetic energy, 1 over c squared energy. It's a measurement of the mass, and depending on the polar or the magnetic field arrangements of the magnetic dipole, whether it's north-south or south-north, we will have a positive or a negative charge being detected. Again, important to stress that these are all Euclidean or flat two-dimensional energies. They may be equilateral, but there is no defined Z component to their fields. They have a distinct positive and negative side to their charge arrangements, but again, this is a result of the equilateral geometry, not a physical property. Doing a Lorentz transformation, or looking at the particle, the field from the other side, will give us exactly reversed field arrangements for the E and M fields. And again, on the right hand side we can see how these equilateral energy quanta come together within any measured energy field or mass energy field. They come together through quantum level bosons adding together. If you have a specific boson, say 5, as these are all odd numbers, you can't add another 5 to this triangle. The next increase of energy must be 7, so that it can create an equilateral triangle. You can think of this as a specific energy or a key that needs to fit into the specific geometry in order to create the correct energy levels. And obviously all quantum energy levels, as indicated here with the formula, increase in square numbers. And again, the square root of the energy is the linear momentum, the square root being the altitude, or the height, more correctly, the height of the two-dimensional energy field. Again, it's always the momenta of the energy field is always in the direction of propagation of the E field. Obviously these bosons come together to form scalar energies, and the bosons are the transverse measurement of charge or of energy momenta within the field. Again, we can also obviously measure it not only in the transverse section, cross section, but we can measure it in line with its momenta or its direction of propagation, which is a longitudinal measurement of the energy content, in which case we will see the pattern here, a distribution of energy quanta within the EM field. Just quickly refreshing and looking at this one, we see that there are 1, and beside the 1 there are 2, then 3, then 4, 5, 6, 7, 8, and then it decreases 7, 6, 5, 4, 3, 2, 1. This distribution from 1 peaking at 8 and then dropping back down to 1 or 0 again, in the case of outside the field, is what is normally plotted as a normal distribution or a bell curve within quantum mechanics. In fact, it's not a nicely rounded curve. It's that way because we plot the lines against our measured energy amounts. In fact, is a equilateral distribution of energy quanta within the field itself. All electromagnetic fields, as discussed in ebook 1, Quantum Mechanics, can be broken back and summarized according to this page. We have positive and negative charges as discussed. There are no magnetic monopoles. The interactions of the fields themselves and particles can all be modeled using the equilateral geometry of Tetryonics. And in the case of photons, the photons are formed where we have two single charged quanta, or 2 h nu, or even numbered h nu in the case of EM fields, forming via coming together inductively and coupling via the weak force. Again, the weak force being the magnetic coupling along the inductive bases of the 0-point fields. Where they couple, they form a stronger Evans photomagneton, as it's termed. It's just a magnetic moment of the photon itself, and obviously it has opposing energy momenta, so it will radiate in both directions at once. In fact, the measurement of how far a photon will spread from its point source in 1 second gives us our base unit of c squared when we convert from mass into matter, and likewise a 1 second measurement of the propagation of energy in a vacuum will give us a unit of c squared. Again, we can measure this in terms of energy or mass, quantized angular momentum, or Planck's constant. And these fields don't always come together as photons. They can in fact form electrostatic and magnetostatic fields, but in all case they contain electric permittivity and magnetic permeability, or EM, properties within the mass energy field, or the mass energy momenta fields. Again, careful to note that in Tetryonics, momenta can refer to the equilateral geometry, which is modelled as a rotational energy flux, but is in fact a physical equilateral geometry, or it may refer to the linear momenta of the system, depending on what properties you're seeking to measure or determine. Obviously, from a point source, in the case of charges, any energy density within a region over a period of time, as measured, will expand outwards from that central point. As it does so, the energy density of that field obviously has to cover a greater and greater area as it expands out and the per second propagation measurements take place. And in doing so, the energy density of that field decreases as the inverse square of the distance. In this case, we have a charge geometry propagating out, which would be heat or charge in a region. If it was a photon, there would in fact be 2 quanta back to back, and it would be a two-directional, a bidirectional propagation of the energies from the point source. Again, just noting here, using the Tetryonic formulation, odd-numbered pi geometries per c squared will give us, we have the energy here, per c squared becomes mass. This is just a measure of the charged mass geometries, or the bosons. All odd-numbered pi geometries, two-dimensional ones, are bosons, electromagnetic charge carriers. They're the quantum levels of the equilateral geometry. Again, photons themselves are 2 pi, as in 2 Planck quanta, to form the complete frequency set of photons, and electromagnetic waves being made up of photons are all even-numbered geometries. In the case of a single geometry, if you were to measure the longitudinal cross-section in terms of frequency or photons, you would in fact find you have half frequencies along the bottom, because this geometry is an equilateral. It's not a 2 pi energy geometry. And again, obviously, the photons themselves are positive and negative charged masses or Planck quanta. As we discussed, the 2 pi or tau pi charged geometries of photons can combine to create electromagnetic waves, and they are all repeating sets, positive to negative, as you measure longitudinally. If you were to measure the cross-section of the photons, you are in fact measuring the quantum levels or the bosons that make up the photons within the EM wave. Again, Tetryonics can color code all this, and as you see here, using the Tetryonic color code for 1, 2, 3, 4, 5, 6, 7, 8, and 9, we can see the geometry of this wave. Obviously, if you were to count the black central ones, you would have an amplitude of 9 for this half photon wave or charge geometry. And again, it would be a square number of quanta within this energy geometry. So in the case of the amplitude squared, will give us 81, or if we like, the square root of the energy will give us the momenta equivalent to the amplitude, which is 9. Tetryonics not only gives us the distribution, the quanta and their distribution, it also gives us clear indications of where the momenta of the energy lies within the field, along with the E and M field properties. Obviously, the total geometry being the quantized angular momentum, and charge is a measure of quantized angular momentum per c squared. As I discussed before, if you measure it in terms of photons instead of quanta as it's measured here, you will end up with half quanta at the bottom. We have a whole one here, we have 1, we have 1.5 or 3 twos, we have 2 whole photons. Here we have 5 halves of photons, or 2 full photons and a half, and this continues. This is obviously with the halves, an indication of that it's measuring the longitudinal photons. Again, if you multiply this by 2, you would change this to an orange to be reflective of the fact that it's a measure of the boson or the charged quanta. So by looking at the quanta instead of the photon pairs, we would have 1, 2, 3, 4, 5, so on, coming to the peak and then dropping back down in the normal distribution or the bell curve. In Tetryonics, we tend to refer to photons as tau geometries, simply because it's a way of distinguishing from charged geometries, which are a single pi. So where you see 2 pi as a photon set of positive and negative back-to-back, inductively coupled, I tend to refer to them as tau geometries. And this, of course, can be reapplied where you see it popping up on the web, where people will see that if instead of measuring the ratio of the circumference to the diameter, we do so to the radius, we can in fact make it into a more rational way of expressing a full rotation within the charged geometries, or within the rotational geometry specifically, of physics. Instead of strange partial pi geometries being generated, as you see here, pi divided by 6 and pi divided by 3, we in fact have something more natural. A full rotation would be 1 tau. Half of a rotation or a reflection will be tau divided by 2. a quarter is tau divided by 4, or 3/4 of a tau for a 3/4 rotation. It simplifies the understanding. Obviously, people that are familiar with using 2 pi for a 360-degree rotation will continue to use 2 pi for this. But in Tetryonics, it becomes a lot easier to look at photons in terms of tau radians and tau rotations. The only real difference is obviously that there's 2 pi to each tau, and obviously instead of 3.14 it becomes 6.28. As we've discussed, there's two distinct ways of measuring the energy content within photons and electromagnetic waves. Planck's formulation was E equals n h nu. Einstein's formulation was E equals hf. They are not equivalent. The energy content is equivalent, but they are different measurements. In this case, we're measuring the odd-numbered bosons adding up to the square energy level. In this case, we're measuring the even or double sets of quanta that make up the square energy levels. And again, this one you can measure all the quantum levels and specify them to make the square energy level, where if you're measuring charge, this one will leave you with half wavelengths in calculating it. Obviously the bosons are odd numbered, or at their quantum level they are single charge geometries. Photons, being the quanta of EM waves, are 2 pi geometries. 1 does not equal 2. Again, all of the properties of EM waves, be it the energy, the momenta, the electric, the magnetic fields, have been researched and studied over the centuries, particularly in the last 2 centuries. And we've measured a large amount of their properties and described them mathematically in a number of ways. What's been lacking until now was their physical geometry. Obviously, we'll never see this physical geometry, but Tetryonics allows us to draw it and understand the interactions that this energy momenta, or mass energy momenta geometry, brings about with the study of light and photons, EM waves, and light in particular. As we've discussed, and as you can see here, in the case of a EM wave, it has a frequency which is made up of the tau pi coupled photons. Each pairing of photons, as you can see here, is one frequency. Again, looking at this illustration, you can see that as you measure this particle, whether you measure it longitudinally or transversely, has an impact on the answers that you get. The transverse measurements will have twice as many quanta as the longitudinal measurements, 2 quanta for every frequency. And again, it's just a way of showing the transverse nature of bosons in quantum levels versus the longitudinal quanta sets that form photons within an EM wave. Tetryonics always displays them, well, in most cases, displays them as you see here. The transverse measures in line with the transverse geometries, and they're color-coded according to the quantum levels and the number of quanta within those levels. And the photons, again, just indicate how many photons at that point. 1, 2, 3, 4, 5, and so on. Again, important to note that in the case of EM waves, etc., their velocity of propagation is the speed of light in a vacuum. If it were to move in a different medium, this speed of c would change accordingly to the refractive index of the material that it's propagating through. Tetryonics tends to stress that it's more appropriate to express the relationship in the more classical terms of wavelength frequency creating a velocity, and that relationship between the wavelength and the frequency is what determines the final velocity, as opposed to just saying that lights propagate at the speed of light. Obviously, using Tetryonic geometry, we can express the boson or the transverse measurements as a geometric representation, along with the color coding for the transverse or quantum levels within EM waves. And obviously we can express and draw with color 2D representations of electromagnetic waves and their energy distributions of photons within those waves. This top one measures the quanta. The bottom one is a measurement of photons, or a wave function of the photons. Top one again gives you quantum levels. The bottom one, as we'll show, gives us wave particle, or specifically wave probabilities for the amplitude and the probability of finding energy particles within any region of space. As we've shown in other lectures within Tetryonics and within the ebooks themselves, Tetryonics is the geometry that forms the backbone of all mathematics. Mathematics, while often described as being the language of science, or the language of physics, if that is the case as a descriptive language, sure, what it's lacking is the geometry that it's describing. And in fact, the Tetryonic geometry that it's describing can also be retermed to be the grammar of the language of mathematics. Mathematics can be formulated and it can be extrapolated from the various equations to give us indications of what is occurring. The geometry that we have here with equilateral energies in Tetryonics shows us what generates that math. And in fact, it's superior to the math in the fact that the geometry sets the stage for what interactions can or cannot take place. And in a number of cases in Tetryonics, it shows where mathematical hypotheses of what's occurring or what is possible from the maths are in fact erroneous, or in some cases completely incorrect. They're based on incorrect assumptions of the interaction at the geometric level. Again, the math itself has a foundation, and that foundation is the geometry. We've been using the math to describe the physical processes, and the physical processes themselves are geometric. Again, just a quick summary. The odd-numbered quanta, h nu, are all odd numbers. They form the quantum levels of all charged square energy levels, square energy fascia or fields. Photons are tau pi or 2 pi quanta. They're measured usually as a frequency, and they come together to form even-numbered EM waves. As you can see here, there is a difference in the geometry of bosons to that of photons, the photons being the diamond shape and the bosons being more of a rhombic shape, creating equilateral triangles as they come together. Obviously, while the bosons create equilateral geometries, the photons will create larger and larger diamond-shaped geometries. Again, these are measurements of energy. If they were measurements of mass, their geometry would be constrained, and we'll see the effect that mass measurements have on energy geometries shortly. Of particular importance, and again this is mentioned over and over in Tetryonics, mathematics and physics to date has poorly defined the distinction between mass, energy, and matter within physics. In the case of relativity, these three terms were in fact lumped together in the stress energy tensor as energy gradients, all of the same energy. There was no distinction between mass, energy, and matter itself. In Tetryonics, we clearly defined mass as a measure of energy, as a two-dimensional measure of energy per second, or per c squared. They're planar mass energies, and whether it's mass or energy that you're measuring is dependent on whether you're using a unit of time for the measurement or not. And in the case of matter, they're energy measurements per volumetric space, or three-dimensional space. So matter itself is a standing wave tetrahedral geometry. Mass is a planar or Euclidean two-dimensional energy form. Tetryonics will list mass energies as n pi because they're all in the same plane, whereas mass energies of matter, and specifically the matter geometry itself, is measured as T pi, standing for 4n pi geometries, tetrahedral geometries, where the tetryon is the matter quanta. Obviously they both contain energies, and these energies can be expressed as n pi as well, just like the mass itself. The difference between the energy measurements and the mass measurements is simply the c squared. And again, over time you will become familiar, and where you see c squared, you know it's mass measurement that's taking place. Where you see c to the fourth, you know that it's a spherical measurement or region of space that's being measured, so therefore it must be a volume or a matter geometry that's being measured in that space. You can still take mass measurements and calculations for matter geometries. Obviously you can divide C4 by C2 and calculate just for the mass content within the matter geometries, and this becomes important in ebook 3, where we're looking at the chemistry and the mass content or mass energy content of matter geometries and that impact that it has. But you cannot take c to the fourth measurements of c squared. So you cannot take matter measurements of mass. Another way of expressing this is that mass is a property of matter, but matter is not a property of mass. So in the case of photons, one of the large debates that's raged over the years due to Einstein's equivalence formula, E equals mc squared, as it relates to photons, is whether they have mass or not. Obviously they have energy and momenta, so therefore it is reasonable to assume they have mass. The fact that they have energy per unit of time is a measurement of mass. Additionally, general relativity claims that photons are bent gravitationally by light near large bodies of gravitation. Tetryonics shows that this isn't the case, but that aside, all mass is a planar measurement of energy per second, as evidenced here with Einstein's formulation. Mass and energy are equivalent to each other depending on your unit of measurement. So it's more appropriate, given that photons are two-dimensional mass energies and that matter is a three-dimensional property of standing wave energies, to term these energy forms as mass energies, or where you're referring to them within gravitational fields, you would in fact term them as matterless energy forms. They cannot form, well, they can form, but they do not possess a three-dimensional property. They are a two-dimensional EM wave, so they are matterless energy form geometries. Or another way to express it, and this becomes clear in the cosmology and the quantum gravity lectures, one of which is available on the web currently, we can reterm them. Instead of matterless, we can call them weightless particles, because they don't possess the property of matter in a gravitational field. They're not affected by gravitational fields at all. They're affected, as we've discussed earlier, through the Evans photomagneton. They're affected by electromagnetic fields. So again, another way to express photons is to say that EM waveforms, bosons and photons, are affected by electromagnetic fields because they are electromagnetic mass energies, and they're unaffected by gravitational fields. There is no effect of gravity on a photon. Again, a lot of people may start jumping up and down saying I'm off track and all the rest. This is clearly all explained with quantum gravitation in Tetryonics ebook 4, and it's obviously not discussed here, but we're labouring over this page so that the relationship between mass, matter and energy is made as clear as possible in reference to photons and EM waves themselves. Obviously, for the more astute listeners at this point, given that we have mass, energy and matter, it's a simple process to do a quick algebraic sum on these, and you'll see that relationship between mass and matter is simply, or the energy content difference between mass and matter comes back to E equals m divided by c squared instead of multiplied by c squared. So again, a symmetry suddenly reveals itself. Here we just divide again by c squared to give us the energy content of matter. There are different things. There is a clear distinction between mass, energy and matter with Tetryonic geometries. It takes a while to get used to them, but it's an extremely important point within Tetryonic theory, second only to the discovery of square quanta being equilateral geometries themselves. Moving on, we can see how charged bosons come together to form photons. This happens, in this case it's giving the example of two single charged quanta, positive and negative, coming together to form a photon, a photon of light, one frequency, positive to negative or negative to positive. This can occur on many levels. You can, as we say, you can add these together. They're square energy levels, and two square energy levels with their individual bosons will form EM waves. So if this was a charge of 4 and a negative charge of 4, obviously we'd have 4 bosons, 1, 3, 3 and 1 within it, and we would have a single frequency. Obviously in the case of photons, they have electric fields and energy momenta contained within those fields. They propagate out at the speed of light in a vacuum as a result of their frequency wavelength relationships. They also have Evans photomagnetons, magnetic moments that result from the coupling of their positive and negative charges. In the quantum mechanics books, in the lectures on equilateral energies, etc., you see that when two opposite charge quanta come together, they form a distinct magnetostatic moment with a neutralized E field. It's the magnetic field that's detectable. The E field is not, because it's neutralized. And again, EM waves contain even numbered quanta made up of 2 pi or tau pi photon geometries and their electromagnetic masses. Again, these masses, because of their velocity, have a property of momenta. So we have energy momenta, mass, momentum, etc., all contained within these geometries of energy. Maxwell was the first to mathematically formulate the relationship between the wavelengths of the electric permittivity and the magnetic permeability and the wavelength and frequency of lights, and he discovered that in the case of a electromagnetic field, a single pi geometry, you in fact have 1 over c squared for the electromagnetic field. Photons have two electromagnetic fields opposing each other back to back. They, instead of being electrostatic, they in fact radiate out from the point source. As they radiate out, taking the square root of the 1 over c squared geometries, we get a velocity of propagation that gives us the speed of light in a vacuum. And that was the first indication for Maxwell, using the electromagnetic field and the calculation of the electric and the magnetic permittivity and permeability, that light itself was an electromagnetic wave. And you can see that calculation quickly down at this corner here in the bottom left. Again, even though this formulation 1 over c squared is correct, it's more appropriate in Tetryonics, for reasons you'll see as we go through, to express it as the velocity of energy in free space, or the natural velocity of energy, as opposed to calling it the speed of light. The photons themselves, being 2 pi energy geometries, contain, obviously because of their equilateral geometries and the fact that they're Planck quanta, they contain quantized angular momentum. In this case, we've again drawn the electromagnetic rotation or flux of energy that represents an ideal quantum inductor, or a 0-point field, and show where they interact via the magnetic coupling, or the weak force in the case of the photons. You can see that there's a clockwise rotation for the positive charges and an anti-clockwise rotation for the negative charges. Again, if you apply a Lorentz transformation, or look at this particle of this energy waveform from the opposite side, you'll see that this would be a negative and this would be the positive. But in fact, it would still be north here and south there. Tetryonics gives the formulation here as h nu squared, because they're square energy levels, and there's 2 of them. There's 2 pi. So 2 masses, 2 charge fields in a photon. Interestingly enough, using the electromagnetic fluxes representing the quantized angular momentum, which in fact is the equilateral geometry, we can see that the flow of energy within any photon is such that it moves around, and where it reaches the coupling, or the inductive coupling section with the magnetic dipole, it has the potential to flow into the other side, from the positive to the negative, circulate through the negative, north to south, and then south to the north internally, and back out again, north to south, south to north. Following this pattern, you can see the familiar symbol, the geometry of the familiar symbol for infinity. It's a quirk. It's one of the many amazing things that you see within Tetryonic geometry. Using the geometry, you find a lot of things popping up over time, relating things back. Obviously, with the strengthened magnetic dipole, we can obviously show the magnetic vector associated with that, and the flow of energy within that EM geometry. Again, wherever there's a magnetic pole or magnetic dipole, there is an electric field, even if you cannot measure that electric field. In fact, in the case of photons, the Faraday's measurement of the rotation of the polarization of light within magnetic fields gave him an indication that light was a electromagnetic field. And in modern communications technology, we rely on this neutralized E field to create motion when we transmit information via radio waves, etc. Obviously, with the Lorentz correction factors themselves, or the beta correction factor, beta itself, or beta, is a measure of the linear velocity per c for energy content, where you get c at the base That's obviously where energy equates to mass. So this velocity, whatever this velocity may be, is a measure of how much energy is within the field, because it is the quantized energy momenta within the field that gives the velocity of the energy field itself. In most cases, the relationship is such that it gives us the speed of, or the natural speed of energy, or the speed of light as it's been termed, within the field. And again, these fields are all square energy fields, squared numbers, so they follow the formulation we have had before. In the case of normally we would express this as a chem field, kinetic EM field, but because there's two of them, photons obviously have the distinction of being completely kinetic energy themselves. They're not a static field. The moment they're created, they radiate out from their point source. They are purely kinetic energies. And in fact, if you look at the kinetic energy component of the chem field, you see that it's a diamond shape made up of positive and negative charge quanta. So you can see the direct relationship there through the energy geometry itself. So we, instead of calling it a chem field, we just term it a KE field, representing the fact that the photon itself is completely kinetic energy. And again, we can say that the mass velocity squared is equal to the Planck quanta squared. In this case, this is a measurement of one direction for the velocity, but there are two. It's a bidirectional field. This formula here is only measuring the velocity in one direction. If you were to measure the other side here, you would get the same measurement. Interestingly enough, photons themselves, as drawn here, are their own antiparticles, the positive and negative arrangements. Within this, you can rotate it round and you get the exact opposite particle. One photon approaching the other one appears as the mirror image to the one that it's approaching. And again, obviously, similar to the linear measurements of velocity against the speed of light, or the natural speed of energy, we can also measure the quanta, or the square energy quanta, as a function of that velocity, that linear velocity, against c squared, to give us beta squared as well. Again, it'll become clearer what the relationship here is with the Lorentz factors, or velocity correction factors, are with wavelength and frequency. In the case of wavelength, Tetryonics can now show the geometry that makes up the wavelength of any measurement or any EM field. The energy within that field has a wavelength that is proportional to its frequency. As you add more quanta of energy to the field, these quanta have to be packed more and more tightly into the same geometry, because obviously it's a measurement of a field per unit of time. So as these energy quanta increase, obviously the wavelength decreases. Tetryonics shows this through the equilateral geometry using alpha, which stands for quantized angular momentum, or the equilateral geometry, per linear c, with wavelength being a linear measurement, hence the name wavelength. Again, in the case of photons, it's the measurement from, in this case, the start of the positive field right through to the beginning of the start of the positive field again. So it contains a positive and a negative wave within each frequency. If we were to measure the boson field, we'd measure individual quantities of positive and negative, and we'd get twice as many waveforms as we do with photons. Obviously they join up, as we've discussed, one to one, and then we have additional photons side by side, but it is the measurement from one point in the electric field cycle to an identical point along that line that constitutes a wavelength. And Tetryonics gives us that formula for wavelength as the geometry divided by the linear velocity, in this case c. Additionally, we can invert that to become c divided by the angular momentum, or the equilateral geometry, the quantized angular momentum, and this is called a wave number. This comes out a lot more when you look at spectral lines, which again is a different lecture. We're focusing on photons and EM waves in this case. But the wave number comes out of Rydberg's formula, which again will be shown to be a measure of the linear momenta of the system, or the photons as they're released from electrons as they transition between various atomic levels. We can use Tetryonics to show us the energy momenta for the electric and the magnetic force vectors within all photons, and again, because they have the same geometry, within all EM fields. And you'll note as we progress through, we start off at a positive field, building to a maximum. As the positive E field degrades, the magnetic dipole increases in line with it till it reaches a maximum. The magnetic dipole at its maximum, or is at its maximum, when the E field is at its minimum. And likely, also equivalently, when the E fields are at their maximum points for positive or negative, the magnetic dipole is at its minimum, or 0 point. There is a point of singularity where the E fields and the magnetic dipoles are minimum. Right at the center, it's within a bar magnet, it's termed the block wall. It's a singularity where there is 0 for all the others, and as in the previous lecture, we show this through the geometry. We show this to be the undoing of special relativity and its explanation of the moving magnet conductor problem. It's these energy momenta that create an EMF in the conductor as it's moved over the magnet to drive the electrons and create a current in that conductor. Again, as we mentioned, the W plus and minus W bosons, equilateral, single or odd numbered equilateral geometry, energy geometries, combine to form a photon of energy, where it is a neutral particle. It is no longer a charged particle, but it is comprised of 2 charged particles, 2 bosons. So 2 bosons make a photon. 2 equals 1. And again, you can also see that the electric and the magnetic fields propagate orthogonally to each other with respect to their geometries and strengths. Touching on the celeritas, or the speed of light in a vacuum, as I've mentioned a number of times now, the speed of light is calculated. It's a relationship that results from the frequency and the wavelength of the energy quanta within any electromagnetic wave. It's the quanta with their energy momenta that create the linear momenta in both directions, positive one side, negative the other, as indicated by here with the colouring of the charge quanta. The negative field has more negative quanta than positive, and the positive field has more positive quanta than negative. In both cases, the net charge is divergent from the point, while the opposite, in the case of the positive field, the negative quanta are convergent. In the case of the negative field, the positive quanta are convergent. So within any EM field, there is divergent and convergent energy fields, and this makes up the law of interaction. However, the net force that results due to the imbalance of positive and negatives is such that you get a divergent linear momentum resulting from the energy momenta of the quanta within these fields. Obviously, there's a negative field and a positive field, so you have one against the other. And if you add up all the positive and negatives, despite the fact that there are 2 divergent fields due to the imbalances, they in fact cancel out to give us a totally neutral particle. Again, a positive and a negative gives us a single photon, or a frequency of light, being neutral quantas. Tetryonics can show us the relationship between the quantized angular momentum, or the equilateral geometry of energy, and the linear measurements that the energy momenta produce due to their imbalances in both the positive and negative fields. In this case, it's simply quantized angular momentum, or alpha, over c. If you do the quick algebra on the units, you get the wavelength, or per m. They cancel out to give us meters. In the case of the frequency, it's c squared. It's a scalar measurement because it's the number of quanta in the geometry. So c squared divided by how many equilateral triangles, or the quantized angular momentum of the system. Doing the algebra again on c squared divided by angular momentum, we get per second, which is a measure of frequency. Combining meters with per seconds, as in multiplying wavelength by frequency, or calculating for the cross product, we get a unit of meters per second, which is a velocity. In this case, it's the velocity of energy, or more specifically, it's normally termed the velocity of light. The older statements, as I've mentioned, term this as v for velocity equals frequency by wavelength. That's more appropriate because c is just a specific frequency where the energy, or the light, is propagating in a vacuum. If it enters a medium, or if the energy momenta relationship changes, this in fact can change. In the case of chem fields, the change of energy momenta, or the frequency wavelength relationship, produces the changes of linear velocity of the electron, or in that case it's the real angular momentum of the electron as it's bound to the nucleus. In the case of light, it will always try to propagate at c due to this relationship, or a velocity that's equal to the speed of light, due to the relationship between frequency and wavelength. Obviously we can do the same calculations again for inverting it for wave numbers, c over a instead of alpha over c. And in the case of c over alpha, we get a unit of per meter instead of meters, because it's the inverse, and that's what wave numbers are. It's the number of quanta per meter, as opposed to the wavelength, the length that the photons take up, their wavelength. Tetryonics obviously helps clear up the distinctions between wavelengths and wave numbers. And in the case of energy momenta within any energy field, obviously we have the relationship of mass velocity, or the square root of energy being the linear momentum. We can obviously reverse that and say that the square of the momentum, or the amplitude, is equal to the energy of the field. One's calculating one way, the other one's calculating the other. Obviously Newton, Leibniz, Maxwell, Planck, Einstein, de Broglie, they've all looked at light, energy, momenta, the quantization of the energy from different aspects. And again, Tetryonics tends to look at it as a velocity of light, v, results from the the frequency wavelength relationship, frequency being a scalar measurement, wavelength being a linear measurement of the energy momenta, or the linear momenta of the system, whereas the scalar is the total energy within the system. They've solved for various things, as you can see here. You can solve for the wavelengths, the Compton frequency, which is again the number of quanta within the field, or Planck quanta nu squared. So nu squared is in fact Compton frequency. The de Broglie number, which is just a linear momentum divided by the Planck's constant to give us a quantized wave number. You can invert that again to give us wavelengths, Planck's constant divided by the linear momentum. They're all different aspects of the same equilateral energy fields. Where they do differ somewhat is where Planck's constant refers to charge quanta, or bosons, and Einstein's formulation refers to photons, and that's where care has to be taken at all times to distinguish between bosons and photons, mass and matter, when you're looking at electromagnetic waves. Obviously the bosons are odd-numbered quantas, as we've mentioned, and the photons are the even-numbered or tau pi geometries. They are very similar, but you will note that in this case it's rotated, but if it was the same direction as far as the propagation of the wave, this one's 90 degrees to what this photon or EM wave is at the bottom, but if they are both the same way, you would note that a boson in terms of a photon is a half wavelength compared to the full wavelength of the photon, obviously, because their energy momenta are all on the same level. Whereas the photons are back-to-back, they're inductively coupled via the weak force. So again, the bosons make up the quantum levels, the photons make up the wave distributions or the wave functions. One's a transverse measurement of energy, electromagnetic energy, charge. The other one's a longitudinal measurement of energy momenta. And again, important to stress that it takes 2 Planck quanta to make a photon. Wave numbers, which we touched on briefly, the inverse of wavelengths. Instead of the length indicated here as the wavelength of the photon, the wave number is simply how many photons are in one unit of linear measurement, in this case a meter. So while the wavelength is 1/3 of a meter, it has a wave number of 3 per meter. One's the inverse of the other, 1/3 versus 3. Obviously we can apply this to the frequencies, we can apply it to the energy content of EM waves, and we do so particularly where Rydberg's formula is introduced. It comes out naturally within Rydberg's or Rydberg's formula for spectral lines. But again, Tetryonics can show the wave number relationship is the inverse of the wavelength. The wavelength, its relationship to the frequency via the speed of propagation, and the opposite, obviously, the frequency being related to the wavelength through the speed of propagation. In all cases, we have a scalar energy made up of quantized energy momenta that are charged, but the total net charge is 0. It's a bidirectional radiant form of energy, and it can also be termed as being completely kinetic energy. It's all energy in motion. There is no static point source. All the energy is within the field itself, and it always propagates out. Most of the time at sea. This can change depending on the energy content of the field itself per unit of time. As we mentioned, photons, a single Planck quanta is a 0-point field, hf divided by 2. They're half wavelengths compared to the photon, and it takes 2 of them to create a photon. We can measure EM fields transversely, and we can measure them longitudinally, and you'll see this is how it's drawn in most cases within Tetryonics. You'll see the field measurements to the top of it will always be in orange to indicate charge, therefore they're bosons, and there'll be a transverse measurement, whereas measurements of frequency will be indicated in blue for their neutral charges, and there'll be longitudinal measurements of energy momenta. Again, the relationship is 2-to-1 for bosons to photons. Obviously, we've discussed a number of things here, how photons can be their antiparticles, etc. That's what's indicated in the center here. We have a generic Tetryonic drawing for a EM field or a photon. You'll always see it drawn as this. This is where we're just indicating the magnetic and electric fields. But if we wish to indicate the charges and the magnetic poles, we can do so again in colour. Aqua being the sum of green and blue, and blue being the sum of positive and negative to neutral. A number of things appear. Obviously, we've discussed the Evans photomagneton. It's an elementary magnet that occurs when two bosons, two charged quanta, interact via the weak force to form a photon. This is done obviously to release energy from a system, and in the cases of photons, they will deliver energy to a system or to a matter geometry and convert back into the bosons. Again, they have, in the case of nuclei, they have to be specific energy levels to create the odd number boson necessary to raise one square energy level to the other, as all square energy transitions require sequential odd numbered bosons to be affected. This mini bar magnet or magneton of the photon, the photomagneton, if you like, of the EM field is clearly shown here, where it's been speculated for a long time. It's evidenced in Faraday rotation of light, etc. But now we can clearly see what creates it and its geometry using Tetryonics. Obviously, with sufficient energies, you can create EM waves with ever-increasing quanta within them, photons within them. Again, as you increase the frequency of the photons or the number of quanta, the wavelength of the quanta becomes smaller because you're packing more and more into the same geometry. They all, as they come together, no matter how many number, they retain the Evans photomagneton arrangement, and in fact, with sufficient energy, they can split into two or more EM waves or photons, and in doing so, they still retain the same dipole arrangement as they had as a full or a larger EM wave. Obviously, EM waves can interact with matter, and in doing so they can increase the energy content of the chem fields and accelerate the matter from one energy level to the other. Again, noting, as we discussed throughout Tetryonics, that any energy added to a system in motion is added to its chem field, not to the matter geometry itself. Matter is Lorentz invariant to velocity changes and is always the same mass matter measurement, whereas it is the mass energy of the chem field, or the two-dimensional energy, that increases as you add energy through either absorbing an electron into the chem field, or as when you accelerate the electron via another force, this chem field has to have energy proportional to its velocity. It's a direct relationship. Velocity, quanta squared. And again, kinetic energy and the magnetic moment of motion. Obviously, with sufficient energy EM waves, or two interacting EM waves, where you have enough energy momenta or Planck quanta within those fields, you can create a situation where you produce three-dimensional mass matter, and you also have energy left over to form a chem field, or the energy of motion for those particles. Again, in both cases, the charge equation must balance. You have neutral charges interacting. They must form charged pairs or neutral particles at the end. The charge is always conserved, as is the mass energies of the particles. So obviously they have to have sufficient mass energy to create the particles and have energy left over to create energy for the chem fields. And if you were to add up the chem fields and the mass matter, or the relativistic fields of these two charged particles, you would come out exactly with what the incident photons or neutral particles had prior to their impact or their collision. Again, as we noted, two bosons make a photon, and they are neutral particles. The energy flux of their systems, if mapped, gives us the familiar symbol for infinity, i.e., whereas bosons can be termed ideal inductive loops of energy, as illustrated and drawn in quantum mechanics, photons can in fact, because of their coupling, be termed ideal quantum transformers. The energy on one circuit is moving in one direction, it couples via the inductive coupling, and circulates on the other side only to return, and this continues in the transformer fashion. There is no stepping up and down of the energy per charge geometry or the voltage. What in fact happens is the energy is at a state of equilibrium within these charged geometries. It doesn't physically flow as illustrated here. This infinite loop geometry and the inductive loop geometry for quantized angular momentum doesn't physically exist. What does physically exist is the equilateral geometry of electric fields and magnetic fields within square scalar mass energies or mass energy momenta. In the case of photonic energy, EM waves, etc., they're obviously 2 pi geometries, and they are totally kinetic energies. Their wavelength frequency relationship of their energy momenta is such that it will radiate bilaterally from the point source at the speed of light, or the natural speed of energy. Again, we can formulate for either one, but taking care to remember that it's 2 quanta for every photon, and that there are 2 masses, charged masses, for every photon as well. If we look closely at chem fields themselves, or the energy fields of motion, particles in motion, matter, we see that the kinetic energy component of the chem field, excluding the magnetic moment that's generated by the motion of the matter, is in fact the same geometry as a photon. It is identical. It's a positive and a negative in all cases. It may in some cases, in the case of a negative particle in motion, be a negative with a positive, just the reverse, but it is always a photon arrangement. So therefore it is appropriate to call photons purely kinetic energy, or kinetic energy as a photon arrangement within the chem fields. They have the diamond shape, everything about them is identical to each other. The only one difference is because of the chem field geometry, the photon energy within a chem field creates a unidirectional linear momentum instead of the bidirectional energy moment or linear momentum of the energy in photons. Again, if we were to lie photons flat and follow the energies, the electric field strengths as they propagate along, you can quickly measure the E field strength and see that it rises up to the maximum, down to the minimum where the magnetic field is strongest. Then it goes to a cycle of negative, back to positive, through negative, and this continues. This is your sine wave of the electric field strengths of EM waves, and again this is a simplified version of a longitudinal wave with 2 photons. In most EM waves you will have photons either side of this as well, so there will be different phase variations, not only between the electric and the magnetic, but between the electric fields and magnetic fields themselves, depending on their how far offset they are from the center of the wave. Looking closely at this, if you would imagine a line between 2 people or 2 observers and move a photon or a EM wave, again identical geometries, past this point, you'll see at the beginning of this point we have a 0 E field that is ramping up. As the photon or EM wave progresses, we come to a maximum positive field, which then begins to taper down. As it's beginning to taper down, due to its equilateral geometries, the magnetic field is ramping up. So at the maximum E field, we have minimum magnetic. And as the electric field drops off, the magnetic field increases. Shown here is only one side of the equation. More appropriately, this should have been shown in aqua. But otherwise, as a north-south, it is one side. It's off the side of what's actually happening. Again, when the E field reaches its positive minimum and starts to go negative, so far as the E field, the magnetic fields are tapering back down as well. We will then reach a maximum of negative, at which point we're at a minimum of the magnetic fields. And again, the maximum E field will begin to taper down as we move on to the next photon of energy. This traces the familiar sine waves of electric and magnetic field curvatures and shows that the equilateral geometry again is the foundation for the mathematics, the sine waves and the maths itself for physics, particularly electrodynamics. These are obviously where you have larger fields or collections of photons. There will be quadrature waves developed that are 90 degrees offset due to the additional photons of energy either side of the central photon. Of course, we can show that the geometry is the foundation, and in this simple diagram we simply show that a positive charge a negative charge black A plus a positive charge B, the two fields combine to give us a photon, a neutral photon, and the velocity of that field is equivalent to the velocity of the energy is equivalent to the speed of light. They're one and the same. And in fact, the other thing that this illustration shows is simply that there is a relationship between velocity and the speed of light, and that's the Lorentz factor. Using these formulations or these geometries, we can open a whole new window on mathematics and how it applies to electromagnetic waves. One of the more intriguing ones that comes out is Euler's formula, a famous formula that relates trigonometry to exponential numbers, to irrational pi, etc. And it's been mulled over for centuries since Euler himself discovered it in the 1700s. The most famous part of it obviously is the fact that you can rearrange it into a number of different forms where you can express e to the I pi as -1. You can also express e to the I pi plus 1 to be 0, because -1 plus 1 gives you 0. And you can rearrange it to e to the ix to give you, or pi will be sine x or sine cosine x, or plus I sine x, or if it's e to the I pi, it would be cos pi plus I sine pi. Tetryonics, using these quadrature or electro and magnetic fields and the normal distribution of energy, quickly reveals that we have positive and negative charge fields, and that the electric is 90 degrees out of phase with the magnetic fields as we plot their field strengths. Again, 90 degrees out is just sine to cosine and vice versa. As we have positive and negative fields, and we know that the square root of all energy is the linear momentum of the electromagnetic field, we can quickly show that in the case of e to the I pi, there is a physical representation. Historically, they've said that it can't be expressed because you end up with the square root of -1. Mathematically, the square root of -1 is impossible, because if they were both negative numbers, you would have a positive number by squaring them. If they were both positive numbers to start with, you would have a positive number generated again. So you can't calculate the square root of -1. Or you can't create a number that you can square to give you -1. Probably more appropriate to say. Tetryonics in the 5th book, Geometrics, goes through all of these relationships, but it does reveal that the linear momenta of negative charge fields is in fact the square root of -1. And then looking at the other formulations here, you can obviously see that if e to the I pi is -1 or a negative charge field and you add a positive to it, you have a neutral photon. So again, e to the I pi is describing the bosons in the electromagnetic field. The result is describing the charges within the EM or the photon. So obviously Tetryonics takes mathematics one step further than where it was stopped. It shows the physical reality to some of the trigonometry within mathematics that has laid dormant and been speculated over for centuries now. Furthering this on, we can look at the phase relationships between photons in an EM wave. As we've discussed, they're a positive field and a negative field, or a net negative and positive fields. The EM fields themselves are made up of a frequency of photons, and the wavelength is determined by that frequency. If we look at the start of the EM field, we have positive and negative fields, but as we go through the central field, we also have, where there's a negative, we have a positive starting either side, 90 degrees out of phase at the same time. These again are just measurements of the boson or transverse geometries as we move along the longitudinal axis. But as you see, they are 90 degrees out of phase with respect to the E fields. And again, as you move further down, you have another E field that is 90 degrees out of phase. As listed here, the sine-cosine relationships of these phase variances within the EM field are shown here. They continue 90 degrees out of phase until they get back in phase at 360 degrees, obviously. And then the phase discrepancy builds up again. This is why these phase arrangements of electric and magnetic fields, or particularly the electric fields, is why solar panels are so inefficient at present. Tetryonic reveals the phase relationships from the longitudinal central axis, or the highest peak amplitude for the wave, because obviously as we move further out from the peak amplitude of the square root, where all the linear momentum is expressed, we're having less and less photons available to give us energy and momenta. And this forms part of the wave function of EM waves. But as you try to collect these waves without a thorough understanding of the wavelength, frequency, and the geometry of the EM waves and their energy momenta, and the phase relationships between the electric and magnetic fields, as you try to collect these on a solar panel, you will be collecting waves that are 90 degrees out of phase with each other. In some cases 100 degrees out of phase with each other, obviously. And as such, it will be extremely inefficient if you try to capture all this energy in a single conductor to draw it away for a battery. What you need to do is you need to calculate the wavelength, and particularly the separation, the longer transverse separation between the photons for their specific wavelengths, and you need to tap off these differing phases, coupling the zero back to the 360 degrees because they're in phase, and take them to a battery. Couple them off in the 4 different phases that are present. 4. Take them to 4 places and then bring them back together for a load. By trying to extract all the energy at once, you are creating a out of phase situation where the energy is being destroyed. Again, this is expressed in the sine waves via the quadrature waves for the electric fields, and they're a natural expression of Euler's formula. Looking closely at the distribution of bosons and photons, we can quickly see that while we have a total quanta number within any EM field, it's made up of transverse bosons, again all odd numbers, with charge, and neutral photons, longitudinal energy quanta or energy sets of positive and negatives or neutral charges. The bosons form the quantum levels, as we've discussed, and the photons create the probabilities. If you look at these in terms of the photons, there are 64 photons, 128 quanta, forming 64 photons, 2-to-1 relationship. Again, you can identify the number of quanta using the Tetryonic color code, 1 for red, 2 for orange, 3 for yellow, and so on, till you reach the amplitude of the wave, or the square root of it, the highest probability. Obviously, there is a relationship between amplitude and probability, and that's expressed in the geometry and the color coding here. The linear momenta is the square of the energy, so it's this line through here. It also matches up with the amplitude of the wave, the highest number of quanta in the waveforms. And again, because we have 64 photons, using the color coding, we can express this as a probability. There is a 1 in 64 probability that we will see a photon of energy this far out from the amplitude of the wave. There is a 3 in 4 probability here and here of finding photons this far out from the amplitude of the wave. There is an 8 in 64 chance of finding photons here, or a 50%, 8 in 64 chance is a better expression. It's the square root. Again, the square root being the linear momenta of the EM wave. But again, we can quickly express all these photon arrangements as probabilities, as opposed to the quanta arrangements being a normal distribution. So we have quantum levels, distributions, and probabilities generated from Tetryonic geometries of energy. We can draw these as wave functions and express them as mathematically as wave functions. Obviously, we have the energies as square energies or longitudinal photons, transverse bosons. We can measure the energy as energy momenta within the system, the linear momenta being the square root of the scalar energy, or again scaling the linear momenta to give us the scalar square energies or square quanta. We can express it as transverse bosons. We can measure and develop a relationship for the frequency of photons and or quanta with respect to their wavelength or wave number per linear unit of measurement. So whether we use time measurements or linear measurements, we get different measurements of scalar versus linear momenta, scalar energies. There's a number of different things we can calculate for within wave functions of EM waves themselves, depending whether we're measuring photons or bosons or transverse or longitudinal energy waveforms. But again, in all cases, Tetryonics gives us a clear picture of what's being measured and how these geometries come together to form these different probabilities and quantum levels, etc. As we just discussed, all EM waves are in fact kinetic energy waveforms. They're all two-dimensional mass energies. They have zero matter components. They're biradial, or they radiate bilaterally from their point sources, and their energy contents a measure of their mass by their velocity, or in the case of light in space, it will be E equals mc squared as opposed to mv squared. But E equals mv squared is the more general and correct formulation for energy mass velocity relationships. And again, if we measure the boson energy content and their geometries and compare it to the longitudinal photon geometries, we see that there is a distinct difference between the geometries and what we measure. It's not just a case of measuring from a different angle. We get different wavelength numbers, different wave numbers within the same geometry and the same unit of energy, all because of the different geometry of bosons versus photons. And again, that's highlighted in the unified field equation by the pi number, or the pi geometry, charge geometry for all mass energy. We're going to express the energy as a simplified diagram which contains both all the functions as one, which is what you see here as energy, or we can break it up into discrete values of frequency, quantum numbers, in the case of separated charges, into voltages or quantum levels. We can see the probability distributions of energy within any EM waveform based on the photons, the longitudinal. We can see the energy contents of each energy level. We can see the geometry of positive and negative charge fields. And of course we can see the fact that where there's a changing electric field, there's a changing magnetic field at any point through the EM wave, and express all of these different functions and features, properties, as Tetryonic geometries of mass energies within EM waves. Obviously, where a EM wave has a specific energy content and then is allowed to propagate from its point source, as it spreads out from that point source, the energy content of that geometry will diminish under the inverse square law, or as it spreads out, its strength will decrease, or the energy content within that field will decrease, and obviously as a result the wavelength will change, etc., because they're all related to each other. Historically, this inverse square law has been explained using diagrams such as you see at the top left hand side, but in Tetryonics it's more appropriate to draw it as illustrated in the center of the page. As we mentioned with all photons and EM waves, they have, due to their coupling, the weak coupling that brings the two charged bosons together to form the photon, a neutral E field is created, but a distinct photomagneton is created. And we can manipulate and measure this photomagneton by allowing polarized light with a distinct orientation to this north-south field to move through an external magnetic field. As it does so, a rotation is noted, and as you move this slightly offset photon back through the field, as indicated at the bottom of the page, it reverses it, so it's clear that there is a distinct dipolar arrangement of the magnetic fields within photons of EM fields. Faraday was the first to note this, and then obviously, having tested for it, expressed the fact that obviously it's an electromagnetic wave. Maxwell then provided the math to prove that was the case. Another effect is Compton scattering, where we can bring in energies to a rest piece of matter, in this case an electron. The electron's at rest. The gamma ray or X-ray incident photon or EM wave comes in. Its energy is added to the chem field, or some of its energy goes to the chem field to create motion for the matter. None of it ends up in the mass of the matter. The matter is Lorentz invariant, so some of the energy in this case has gone to the into the chem field as mass energy in the chem field, and obviously depending on what velocity is created, there will be an associated frequency wavelength relationship within that chem field that changes to produce that velocity. And this again is why Tetryonics tends to state the frequency wavelength relationship as a velocity and not refer to it as C. And again, any energy that is left over and not required to create the square energy level of the chem field is left as a photon of light, in this case a degraded photon, whose wavelength in this case is clearly longer than the incident photon. This process is known as Compton scattering. Newton was the one who showed this, that white light is in fact the result of many colours combined together. We can show this with Tetryonics. We can show that in the case here just prior to the prism, the white light is made up of all the frequencies of light within the one charged or one EM wave geometry. This incident white light, with all its frequencies superpositioned, interacts with the prism, and here the velocity, which is the relationship between the wavelength and frequency, and because there are different wavelengths and frequencies of light here, they will split out with different velocities, or they will refract within the medium, in this case a refracting prism, and they will split into their constituent colours. Again, it's the familiar spectral colours, the only difference being that Tetryonics specifies an aqua colour, so that we have 8 distinct colours for the 8 transition levels within atomic nuclei for spectral lines. Again, all the properties of electromagnetic waves, be it velocity, angular momenta, as in geometry, equilateral geometry, frequency, wavelength, relativistic energy, and by that we mean where the energy itself, the geometry, its wavelength changes due to its velocity, the linear momentum of the system, a function again of the square root of the wavelength by its frequency, its kinetic energies, which is what light is, the magnetic moment, the Evans photomagneton. All these properties can be expressed with equilateral geometry. And in doing so, we can describe them mathematically as a wave function for any EM wave. A lot of speculation has gone over the years as to exactly what the wave function is describing, and it's the foundation for a lot of the probabilistic statistical mechanics and mathematics within quantum mechanics, particularly QED. Presently, Tetryonics, again, the geometry is the foundation for the mathematics, and using the equilateral geometry of energy, we can show the geometry of the EM waves and what gives rise geometrically to the mathematics of the wave functions themselves. In doing so, we remove a lot of the speculative nature about photons, light, EM waves, etc. And in another lecture, we'll in fact remove one of the greatest hurdles, which is wave-particle duality. We're not covering wave-particle duality in this lecture. It'll be a completely separate lecture. Again, with sufficient quanta or photons of energy within the EM wave, we can create pair production, as it's known. We can convert two-dimensional mass energies into three-dimensional matter with kinetic energy of motion. Obviously, this can occur two ways. You can have a single EM wave that can split and create a pair of particles with kinetic energies. Again, the total relativistic energies and charges of the pair that are created must equal or the equation must balance to give us the original neutral energies that brought about their creation. And likewise, this process can be reversed, where you slam two opposite charged particles together with their kinetic energies of motion, and in doing so you convert the matter back into radiant mass energies. Again, noting that while the charge and mass energies are conserved, the matter is non-conservative. So what you have is matter being converted into mass energy, or mass energy being converted into matter. The matter property does not transfer over like charge and mass energy conservation does. This opens the door to a number of clean energy alternatives for humanity and future civilization growth. The other way that this can obviously occur is if you have two photons of energy, or two EM waves with varying amounts of photons. In this case, they're equal numbers, they're identical photons of energy, colliding or interacting, and again they will produce matter geometries with kinetic energies. If you add up the mass matter and the mass energies of the chem waves, you'll balance out with the original incident EM waves of photons. And again, matter is non-conservative, but mass energy and charge is conservative. Two neutral particles enter the collision. The particles that exit must add up to a neutral charge and have the same mass energies. The matter is not conservative in this case. And again, Tetryonics shows how this is all made up of matter and mass energies, using the unified formula for energy, where we can express it as mass alpha nu squared, or Planck's quanta squared, or as classically as mass velocity squared. The relationship is a geometric relationship. Either expression of energy is correct, so long as you define that it is a square energy level that is being created. And again, two quanta make a photon. So if we were to express it as frequencies of light, they'd be photons. If they were measuring the energy quanta, or the Compton frequency, it would be twice this amount. Again, we can show the Compton frequency in respect to rest matter, or mass matter, and compare one to the other through the unified field equation. This is another picture showing the various relationships of photons to electromagnetic fields, in particular to the EM field geometries. You'll see that this EM field, even though it is comprised of differing or smaller photons of light with constituent charged energy momenta, in fact its final geometry is just a bigger version of the constituent photons of energy. So one is a scale of the other. An EM wave can be described using photon geometry and vice versa. The difference is just the energy density of the wave, and obviously the amplitude, or the square root, the momenta of the wave, gives us an indication. We calculate for the square root, which is obviously the square root of the squared energies. By calculating the square root, we can then quickly determine the probability associated with energy, or finding photons within that EM wave geometry. Again, the electric fields and magnetic fields are 90 degrees out of phase with each other, and the photons themselves, as you move out laterally from the central amplitude, are 90 degrees out of phase with each other. The illustration at the top left hand corner is slightly incorrect so far as it only maps a single M field, not the dipolar magnetic field that is present in the reality. As indicated at the top right, there is a dipole that varies in direct relationship to the E fields. This page just simply looks at the phase relationships between the electric and magnetic fields within EM fields. Take a closer look if you want. I won't go into great detail here because it will become laborious to explain. But again, just note that there is a 90-degree phase relationship or a sine-cosine relationship between both the E fields and the M fields, and again between adjacent photons in the EM wave, of which only the amplitude photon is shown here on the right hand side, and then above it is shown the E field arrangement, positive, negative, and then the M field. Again, this will be drawn in a normal illustration or a classical illustration in most textbooks as just a M field changing in relation to the field, to the E field. In the case of Tetryonics, we can show the dipole changes of negative, of north-south within that M field. There exists two ways of propagating waves, and this is highly misunderstood within electrodynamics. Maxwell formulated for transverse waveforms where the E and M fields were orthogonal to themselves. One was E field pointed one way, M field was the opposite, 90 degrees out of phase if you like, and these two fields moved with the energy momenta transverse to their direction of propagation. In this case, the Hertzian or Maxwellian forms, the transverse waveforms, is the form that you see in the center of the page, where the M field is in this direction, the horizontal direction of the axis, horizontal axis, and the E field, and the linear momentum obviously, is in the vertical direction. Obviously then this wave, if you think of it as a sail, then propagates as an entire wave of orthogonal E and M fields in the direction towards V. This is the transverse or Hertzian Maxwellian waveform that's described in Maxwell's equations. There exists another form which was generated by Tesla through spark gap technologies. When the energy is released in this form, the EM wave geometry is distinctly different in that the E field and its energy momenta is in the same direction as the direction of propagation. The M field is still orthogonal to the E field, and it still follows the same mathematics as the transverse field, but the energy momenta in the case of Tesla waves or longitudinal waves is in line with the direction of propagation. These longitudinal waves, as they're termed in Tetryonics, have their energy momenta in the same direction, whereas the transverse waves have the energy momenta transverse to the direction of propagation. The Maxwellian or the transverse waves are like a sail moving in the wind, whereas the longitudinal waves are more best described like a knife cutting through in the direction of propagation. Again, they propagate in both directions at the same time. In the case of longitudinal waves in this picture, it will be a horizontal propagation in both directions, whereas in the transverse waves they'd still propagate horizontally, but they'd also have energy momenta in the vertical direction. They are both EM waveforms, and they are both described through Tetryonics as well as Maxwell equations identically. The only difference is the direction of momenta within the EM waves themselves. Maxwell will see the different ways of producing these waves as we progress. Maxwell's waves or Hertzian waves are measured via their frequency per second, or the number of waves, the number of cycles per second. It's given the name Hertz, as it was Heinrich Hertz. They finally physically produced the waves that were described by Maxwell in his equations, and paved the way to AM and FM radio and other forms of transmission. Tesla, on the other hand, was producing longitudinal waves, and as such, instead of a frequency measurement per unit of time, his method was producing a number of quanta, or joules of energy per second, volts per second, because it's again quanta per charge geometry, or energy per charge, which is a measurement of voltage per unit of time. And that gives us a means of differentiation between the two. Again, they still both utilize equilateral energy geometries. However, in this case, the geometry shows a distinct difference in the arrangement of energy momenta with respect to their direction of propagation. Looking at this central picture, we obviously have a Compton frequency, or a number of photons, creating an amplitude. In Hertz's case, we vary the amplitude. So as you see the different colors per second propagating along, you know that it's a different number of quanta, or different Compton frequency, and accordingly a different wavelength for the photons in these waves at any particular instant of time. This gives us frequency modulation and amplitude modulation, obviously. As we vary the amplitude, we can also vary the frequency. In the case of FM modulation, we maintain the frequency of the EM waves, and we vary the number of waves per second. Tesla was packing energy into these waves, into these charged geometries. So we have the same geometry, but he was increasing the number of quanta per second, or per charge geometry, the voltage. In doing this, he obviously increases the energy momenta within these charged geometries. Additionally, his charged geometries, instead of standing upright and producing an amplitude modulation, arrange themselves so they are in line with their direction of propagation. In case of a spark gap, they radiate both directions from the spark gap. In the case where a spark is created and it propagates along in one direction, again, the energy momenta of the quanta making up the voltage aligns in such a way that even though there are convergent and divergent energy momenta within the geometry, there is a net divergent or linear momenta that is created. And again, this linear momenta is in line with the direction of propagation. And this explains why Tesla often reported in the earlier days of his experimentation that when the circuit breakers were closed in his laboratory, that on occasion he would feel stinging rays striking his face. This was in the early days of quantum mechanics, and electrons had only just been discovered by Crook and others. And he investigated this, and in fact was able to determine that they weren't electrons that were hitting his face, it was something else. In fact, where large voltages were used, closing the circuit breaker would in fact kill unprepared research assistants in his laboratory, and have resulted in deaths ever since. Wherever you're closing the spark gap, you create longitudinal waves by virtue of the fact that it is a spark gap. It's a release of energy momenta within a time frame, as opposed to the frequency measurements. These momenta are lined up and they strike you like a knife. It's the difference between a slap on the face and a karate blow with the fingers directly to the throat. One is just side-on, transverse. The other one is a direct blow where all the energy is focused in at the point of impact. This is the major difference between longitudinal and transverse waves, Hertzian technology, and Tesla's technology. The mathematics describes all of Hertz's waves, but it doesn't describe the geometry of Tesla's waves. Tesla was largely ignored despite his great contributions to our understanding and development of electricity in technology, and it's to great regret, because had we utilised Tesla's technology, we could have well been on the way to developing more advanced technology so far as electricity and putting electricity to work for us. Again, there's lectures on electricity within the YouTube and Google Plus channels. Avail yourself of them and you'll see how we developed Tesla's ideas as opposed to our current technologies to create clean, limitless energy using Tetryonic knowledge of charged geometries. Obviously, in the case of Maxwell or Hertzian waves, we create these waves by oscillating electric charges, in this case electrons. As we oscillate the charges, as we change the dipole to oscillate the charges, obviously the electron will have a chem field created, because the matter is invariant to motion. All the energy is stored in the chem field. But as the dipole reverses in this chem field, the electron must come to a stop, in which case it releases this energy as bosons and photons in order to pick up to be accelerated in the opposite direction. And this repeats a number of cycles per second. And in doing so, it releases the energy of the chem fields as transverse electromagnetic waves. Tesla differs from this process in that he created his longitudinal waves through spark gaps, where the energy momenta, as we've discussed, as illustrated here, are in the same direction as the direction of radiation or the direction of propagation. So, in summarizing, accelerating charges, and that includes decelerating, produces transverse EM waves, whereas using spark gaps and plasma discharges produces a longitudinal wave. They are completely distinct EM geometries formed from identical charge quanta and or photons, 2 quanta to every photon. Again, just to repeat that, they have identical photons. It is the arrangement or the direction of the E field energy momenta with respect to the direction of propagation that changes it from being a transverse to a longitudinal wave. Obviously, there was a heavier reliance on the fact that Maxwell formulated a transverse wave, or the mathematics for transverse waves, and with physics relying more and more on mathematics, it was Maxwell's discovery that was picked up and developed using the mathematics, and that uses oscillating charges. We've now almost completely moved away from spark gaps for our transmissions and creation of EM waves to oscillating charges. And in fact, most of our computers and solid state devices no longer have spark gaps. Spark gaps were common where we had valves, etc. They are no longer, due to the solid state nature of electronics and radio transmissions. So we've lost a lot of the information and development that Tesla did with longitudinal waves, and in some cases it's actively discouraged as a crank or a misguided technology, because the mathematics describes transverse waves but doesn't describe the longitudinal waves. Again, the geometry shows us the way. It's the geometry that is the foundation for the mathematics, and once we have the geometry in place, we can reveal the differences between the two and then put the differences to use within technology. This is just a clearer example of accelerating an electron with its chem fields to produce the transverse waves. As you can see here, the electron's accelerated in this direction. Well, a stationary electron that is accelerated, the matter doesn't change firstly. the rest mass is invariant. What happens is the energy momenta is added to the chem field. This creates kinetic energy of motion to a velocity that's proportional to the square root of the number of momenta in the field. Obviously, in addition to the kinetic energy, there exists a magnetic moment will be created for the charged particle in motion. This is in complete contradiction to special relativity and how it describes magnetic moments being created through the motion of matter. But this is again the correct explanation for the physics of quantum electrodynamics, or the motion of charged matter in motion, and it will replace special relativity. Moving on, you can see that when you accelerate the particle upwards along the page due to a positive charge above the particle attracting it, and you can see the energy momenta of the electrical field illustrated in here. And again, these electricity and energy momenta are explained in much greater detail in the previous lecture. But we accelerate it one direction with the dipole in this direction, then we reverse the dipole regularly per second at a set rate. As we reverse the pole, obviously it has to transition to its reverse dipole arrangement, but in doing so the electron comes to rest. When it's at rest, it no longer has energy in its chem field because the velocity is zero, so it must give up all this energy that was acquired due to its motion in order for it to then be accelerated in the opposite direction. So we create a chem field, we release that chem field, and we create a reverse chem field. We then release that chem field by stopping the electron, and then we induce more energy momenta into a chem field, again using electrical energy from the energized field or the electricity to do the work in accelerating the electron or the charged particle one direction or the other. And it's this acceleration, which is obviously means deceleration as well as acceleration, a poor English word for what's physically happening, but accelerating the particle produces the transverse waves. In the case of spark gaps, this energy is released abruptly. It's stored up and released as a voltage release, a discharge from the point source, and it radiates out as electrical energy or as a longitudinal wave. We can look at the chem waves obviously and refer the changes of velocity and relate them back to the mass energies of the field and describe them as changes of momenta in the chem fields. Either direction is still a change of momentum as we go from the velocity that's created by the electric field to the zero velocity to a velocity in the opposite direction as a result of the changing dipole. By relating it to the square root of the energy or the momenta of the field, the mass velocity, changes of the momenta can simply be re-expressed as another form of Newton's second law, F equals ma. Again, acceleration, you can reword the acceleration to changes of momenta over time, or mass velocity over time, or again velocity mass over time. You can change the expression, but all of it is clearly illustrated here using Tetryonic geometries of both mass, energy and matter. Something that can't be done using traditional physics and or even the most advanced math presently. A little note here at the bottom, which is important to point out, I suppose, as we discuss these things. A charge or an electron with a constant voltage, as illustrated on the left-hand side here, if this velocity wasn't changing or it wasn't accelerating, would produce what's called a reactive field, or a chem field, where we have electric and magnetic components Obviously, through the electric field, we can interact with other charged particles through the Coulomb force, and that'll be explained in other lectures as well. Or alternatively, if we have electrons passing each other in a conductor, either in the same direction or opposing directions, again we can use the magnetic field geometry to explain Ampere's law and other circuital laws that exist for EM fields, for particles in motion. So we can describe a particle with a constant velocity as having reactive fields. They can react with other particles in their environment or with their environment to bring about forces. Accelerating charges, because they have to give up their energy as they accelerate and decelerate, produce what are called radiant EM fields, i.e. transverse fields. So again, Tetryonics shows the distinction between reactive EM fields, or chem fields as they're termed within Tetryonics, as opposed to transverse radiant EM fields that are produced by accelerating charges, accelerating, decelerating. They're the same term. Again, any changes of energy may not be instantaneous, so as the velocity decreases, the squared energy levels decrease in proportion to the velocity, and they do so by releasing bosons, or odd-numbered energy quanta, bosons of energy which then couple to form the photons of EM fields, or transverse energies. The transverse waves, as we've discussed, are like a sail or a slap in the face, and that's what's illustrated in this case. We have neutral EM fields with a distinct orientation to the energy momenta, which is orthogonal to the direction of propagation. It's transverse to it. Again, they still have orthogonal M fields with respect to their E fields, but from the perspective, if a wave was propagating towards you, as illustrated here, you would see the magnetic dipole, or the Evans photomagneton, and its specific orientation with respect to the E fields. Again, you wouldn't detect the E fields, you would detect their effect on charged particles that they interact with. In total, they are a neutral field. But the energy momenta is up and down, like a hand raised to slap you on the face. And that's what's illustrated here. Neutral fields with positive and negative charges that are again neutralized, moving towards you as like a sail billowing in the wind, or as a slap in the face. We can obviously increase the amplitude, or the energy momenta frequency of these waves, and in doing so we create an AM, or an amplitude modulation. As we increase the amplitude, we can encode information on that wave. In fact, we do so by having a carrier wave, and then we superimpose the amplitude modulation on that wave, and that will produce a upper and lower sideband, as it's called, of identical waveforms about the carrier wave. The carrier wave gives us something to lock onto. The upper and lower sidebands are identical waveforms, 180 degrees out of phase, but they're identical because of the amplitude of the wave where the information is encoded, and they propagate along as transverse waves. This was the early form of radio. It was subject to interference from lightning, etc., because when lightning discharged, it would add energy to the amplitude of the wave and create a spike, and when you're listening to it, you'd hear the crackle, etc. That's why upper and lower sidebands were handy, because they could filter out some of that induced energy from the wave to give us a cleaner signal. We then translated from amplitude modulation to frequency modulation, where the wave itself didn't vary in its frequency. All the waves were exactly the same frequency, and we could lock onto that specific frequency of as a carrier signal. It was then the number of waves that arrived per second that created the encoding. It was more of a digital format as opposed to the analog AM wave, whereas the AM wave had this analog amplitude to it. Information encoded in the frequency modulation is done by increasing the number of identical waves that arrive per unit of time, and we then use that frequency to find the signal in the first place. Different formats using the same waveforms. Again, I won't go into this other than to say that obviously in addition to transverse and longitudinal waves, we can in fact polarize waves themselves. It's not really well drawn here because we're trying to represent a rotation about an axis in 3 dimensions on a 2-dimensional page, but it does, to a limited fashion, show us the difference between horizontally polarized E fields and vertically polarized E fields, as opposed to a circularly polarized E field of a wave where it's in a circular fashion, or a light source that's completely unpolarized where the E fields are in any direction with respect to its direction of propagation. And that's illustrated in the central pictures here with the faces. Obviously, we've explained amplitude and frequency modulation. We can do the same things with longitudinal waves. Once we establish the waves with their aligned energy momenta with respect to the direction of propagation, we can modulate the energy momenta or the voltage of this established waveform, providing it's continuous. And interestingly enough, because the energy momenta are aligned, as we increase the energy impulse, say at the spark gap source at the center of the waveform, it's immediately transferred to the distant end. Just again to be clear, variations of voltage in an established longitudinal EM wave, because of the arrangement of energy momenta in the direction of propagation, those voltage changes will be instantly propagated by the momenta of the system, of the wave, to the far end. You can think of this as akin to a number of people holding broomsticks together in a long form. While it takes a while for the broomsticks to be handed over between the participants around the oval, for example, in a baseball field or a football field, once you've handed out all the sticks and everyone's holding a stick, if somebody was to suddenly push in both directions or in one direction at one stick and they all were touching together, that would almost instantaneously propagate round to the other end of the field. It would be a very rapid transmission of the information from the source to the far end by virtue of these aligned momenta within the fields. And in fact, this is an important discovery within the geometry of Tetryonics and a distinction between longitudinal and transverse wave technologies. And it also offers an explanation and provides a mechanical basis for Newtonian action at a distance. And again, cosmology lectures cover this in more detail, but the longitudinal waves in fact have an impact at a cosmological distance and create action at a distance. We can produce these longitudinal waves with their aligned energy momenta, obviously, by having a large voltage source at one point and then discharging this high voltage or EMF rapidly in a spark gap or similar, rapidly discharging or allowing this voltage to come together to create a spark. The energy momenta that's created will propagate rapidly compared to that of a transverse wave. And in fact, all the mathematics currently refers to transverse waves, not longitudinals. You can obviously short-circuit the voltage potentials to create this spark, or you can build up the voltage to the point where they explosively discharge between the gaps, which is Maxwell's I've forgotten the term. It's the added term that Maxwell had to add for capacitive discharges within circuits. He had to add it to his equations in order to explain them. As you build up the energy momenta per charge at the source, you're obviously building up the voltage. When this builds up to sufficient levels, it will create a breakdown between the charged source and a source of ground or a return source back to the other side of the voltage separation. It's a discharge of the voltages between the points. That's the approach Tesla took to his work. He increased the frequency of the quanta discharged per charge geometry, or per unit of time, which is just another expression of voltages. High frequency discharges are by nature very large voltages, and that's how Tesla coils work. That's the approach he took, and he strove to explain that his was a longitudinal wave that produced this stinging sensation by virtue of the longitudinal nature of the waves. He didn't express it as energy momenta, however Tetryonics clearly does. In this case, we've drawn the EM field between the spark gaps, and you can clearly show the arrangement of energy momenta and how once it's established you can conduct momenta extremely fast between one end to the other, just like you do when you switch on a light switch. The electrical energy flows faster, almost instantaneously, compared to the drift velocity of electrons in the circuit. In fact, the drift velocity is a secondary effect where energy is being wasted, electrical energy is being wasted, accelerating free charges in the circuit. That's something that should be avoided at all times, and in fact that's what Tesla was striving to do by having his circuits inductively coupled from the source to the load, and having circuital loads that are inductively coupled. The field is established. You can transfer the physical energy momenta, the unit of force, almost instantaneously from one point to the other without wires. You inductively couple into the field, tap off the energy that you need, and within a closed circuit, just like normal electrical circuits, you then use the energy that you've tapped off in the closed circuit to do work. You can see here the polarization of the longitudinal waves with respect to their direction of propagation. Again, identical energy quanta to transverse waves. What differs is the orientation of the momenta of the energy with respect to its direction of propagation. A clearer picture here showing voltage sources, separated potentials, EMFs, however you wish to describe them, separated charged dipoles in a generator or a battery, charge plates. As the energy momenta builds up within the charged plates, the voltage obviously increases. This allows for a breakdown and a discharge of energy, or in the case of a spark gap, it'll build up to a voltage, and then this voltage will seek to equalize through the second law of Tetryonics. In doing so, it will spark, and this spark is a longitudinal wave. Worth of note is the fact that the energy momenta within the longitudinal wave has convergent and divergent momenta. That is to say, the positive charge field will push out positive energy momenta towards the negative, and the negative will push out negative energy momenta towards the positive as they seek equilibrium. It's when these momenta are established between the two, if you continue to have this longitudinal wave, once it's established to be maintained, that you can transfer momenta impulses as information almost instantaneously from one end to the other. This, in fact, the velocity of propagation has been measured by Charles Wheatstone back in the 1800s, well before our current technology and our current math, particularly regarding transverse propagation, where we tend to state that electromagnetic waves propagate at the speed of light in a vacuum. He measured the spark gap energies, and he did so as illustrated here with 3 spark gaps, where he could time the 2 end spark gaps, make sure they were synchronized, and time the time it took to get to the 3rd point once the other 2 had sparked. He then increased, he did this between the spark gaps with coils of wire. He then increased the length of the wire so they had to travel further and further, and timed the time it took for the sparks to occur once they were generated by the voltage source. In doing that, he actually came up with a formula and an estimate for the speed of propagation, and that speed was 470 million meters per second, well in excess of the 300 million meters per second of the speed of light. Again, revealing that the aligned energy momenta can propagate information faster than the electrical energy can move along the circuit itself in establishing it. And this number turns out to be pi on 2 by the speed of light, so it's greater than the speed of light. And again, it shows that by aligning the energy momenta in longitudinal waves, we can in fact not only move electrical energy faster and information, but we can do work at remote distances almost instantaneously, because obviously any impulse at one end or the other will be relayed almost instantaneously to the distant end, because all the energy momenta are aligned. Obviously, Tesla, in experimenting with voltage and Hertz doing frequency, they were different aspects of the same thing. The frequency of a transverse wave is just a measure of the amplitude, if you like, of that wave. Voltage, again, is just the number, the Compton frequency, or the number of energy quanta per charge geometry. So they're all different aspects of the same measurement. We can measure them in frequency, we can measure them as wavelengths. There is a distinct relationship between frequency and wavelength to the velocity of propagation. And again, the frequency itself, as it's a measure of how many quanta form the scalar energy of the EM field. Again, c squared divided by alpha, where alpha stands for the equilateral geometry or the quantized angular momentum, gives us frequency. C squared scalar geometry divided by the quantized geometry gives us the frequency of particles or charged geometries within any field. Obviously, again, as we've mentioned, you can increase the kinetic energies of particles, etc., and by accelerating the particles, the electrons, you can create EM waves. In fact, Tetryonics in the chemistry discussions shows that that's exactly the process used in creating spectral lines. The energy levels of the deuterium nuclei in the atoms affect the chem energies of the bound electrons, and instead of being free to accelerate away from the nuclei, they're bound to it, so their rotational angular momentum increases because they're bound. Any changes to the nuclei energy results in a change to the chem energy, same as changing the velocity or the acceleration of the linear acceleration of the particle. In doing so, the energy field, the chem energy, has to give up bosons of energy so that it can change from one velocity to the other through the squared quanta of the energy. Again, same process, and again, light is a form of EM radiation, so the atoms themselves are just showing us another example of how to create EM waves. And in fact, as mentioned in the chemistry lecture and spectral lines, the deuterium nuclei is in fact a quantum model of Tesla's rotating converter or energy storage where DC energy was stored in a flywheel. The energy of the nuclei is stored in the rotational motion of the electron. And when energy is required or removed from the electron, the rotation rate of the electron changes. So again, we can quickly show on a quantum basis what we've discovered and perfected over the years in the macro scale world of electrical engineering. These energy changes of chem fields, as we've just discussed, are illustrated here. In this case, we're showing Rydberg's constant, which is just a measure of the linear momenta of the chem fields. Again, this is discussed in much more detail with spectral line emissions. But the Rydberg's constant will give us the physical changes of linear momentum, and obviously this is related to the wavelengths of bosons and energy quanta photons, and these can be measured either as wavelengths or alternatively as the quanta per unit of length, which is wave numbers. And you can see here Tetryonics reveals the Rydberg's formula, or Rydberg's constant, for each of the spectral lines within the atomic nuclei that's possible. We can then represent all the transitions or the production of transverse EM waves, spectral lines, using a stylized version of the side elevation of an electron. And you can see in this illustration we have the bosons making up the square energy levels of the chem field, and its transitions between these energy levels as they're marked in as circles within this picture. Energy levels 1 to 8 within the bound atomic nuclei. We produce the spectral lines, all the spectral lines, and we've in fact documented within Tetryonics each and every spectral line and the frequency and the energy geometries that it takes to create them. That's another lecture. And of course we can relate this to wave numbers and linear momentum, as we've discussed, and it's just the transitioning between these various energy levels that gives us a different Rydberg constant for each of the spectral lines that's available. And again, matter itself is Lorentz invariant. All the energy of motion is stored in the chem field, the kinetic energy, and it's the addition of the invariant mass matter to the variant mass energies of the chem field that gives us the relativistic energies of matter in motion. The matter itself does not distort due to its motion, as explained in special relativity. So again, spectral lines can be shown simply as acceleration of point charges, just like they were in the Hertzian method of accelerating a charge, oscillating a charge to create the transverse waves. That's precisely what the atom is doing. It's varying energy levels create angular momentum in the electron as opposed to linear momentum in the case of oscillating charges. But the same thing, as the energy changes, the momenta must change, and in doing so it releases bosons that create photons of light. A closer look here, or a larger picture, shows us the relationship between velocity and the speed of light, as we've discussed. They're both identical, but it's more appropriate to say velocity of energy, because it is energy momenta that creates the velocity, and it's the relationship between the frequency and the wavelength that gives us specific velocities for different mediums. Again, transverse measurements gives us bosons of energy, or charged bosons, which are formulated as E equals h nu. Again, E equals hf describes photons of energy, or longitudinal measurements of plus and minus charge boson pairs, and these are described as wave functions. Again, the amplitude of the wave will give us the statistical probability of finding specific energies within that wave. Again, all the statistical mathematics is simply us trying to derive the geometry. We now know the geometry of energy, or the square energy levels, or the square quanta of electromagnetic waves are equilateral. And using this geometry, we can now draw the foundational geometry to all quantum mechanics, QED, cosmology and chemistry. And we can of course formulate it with the unified field equation for photons and or electromagnetic fields. The lines in this case represent the various quanta, with the colours representing the energy of the scalar energy of the field. As we've discussed, white light itself is simply superpositioned wavelengths or varying wavelengths of energy within the EM field, in one complete EM field, and we can decompose these or split these frequencies out by passing them through a medium where the refractive index is different, i.e. a prism or something similar, or a spectrometer. And by splitting them out, we can measure the strengths and intensities, or the frequencies and wavelengths of the constituent EM waves or photons within the EM wave. This gives us the basis for spectroscopy and analysis of distant stars, etc. And accordingly, it gave us the spectral line emissions, gave us Planck's constant and the foundation for quantum mechanics. Newton was in fact the first person to describe light as a corpuscle of energy, or of a particle. When Young came along, it was then dismissed as being a wave, and much debate has gone on ever since as to the true nature of light, whether it is photons of energy, which Einstein then brought back into the fray with the photoelectric effect in electrodynamics, or whether it is in fact a wave form as described by interference patterns and Young's work with wave interference patterns. This forms the basis of yet another discussion regarding light itself, and we'll move on to that possibly in the next lecture or the one after. Obviously, the final thing to summarize here is that irrespective of its frequency and its energy content, light and the equilateral geometry of electromagnetic fields forms the basis of all energy, be it heat, light, or even stronger fields such as electricity. Tetryonics gives us the geometric tools to draw the electric and magnetic field properties and mass energy momenta properties of all EM fields, all light and radiation, and apply this knowledge of frequency, wavelength, mass, energy, momenta back to EM waves specifically. And of course, using Tetryonics, as you've probably no doubt heard in the other lectures, we can now split up and differentiate between mass, energy, and matter in its various forms, show the relationships between them, and further advance our mathematical understanding of the properties as well as their geometric properties. And we can also clearly define the difference between two-dimensional mass energies and three-dimensional matter. So accordingly, dependent on the frequency or the mass energy momenta quanta of each EM field, we can then describe things like black body radiation, as Planck did with his heat law, as chem fields in the case of particles in motion, and express the fact that the matter is Lorentz invariant. And we can also express it in terms of larger scale effects like electricity, and even the EM fields of stars and how they use the electromagnetic field geometry to create their energy. In that, we'll leave the discussion of photons and EM fields and light and we'll close the discussion at this stage. I encourage you to look through the second Tetryonic book on quantum electrodynamics for a further discussion on this. The next discussion we'll move into, or the next lecture, will be that of wave-particle duality and wave interferences. Thanks for your time.